I would like to express my gratitude to the scientific committee of the first conference on cancer prevention for primary care in Latin America and the Caribbean for inviting me to participate in this important event, given the widespread importance of cancer in Latin America, and in particular to talk about a topic that I really enjoy and like, which is evidence on weight control in relation to cancer. It is an honor to participate in this session. It is estimated that in 2018, there were 18 million cases of cancer in the world, about 9.5 million in males and 8.5 in females. Cancers can affect anyone, but some are at higher risk than others. A wide range of risk factors are modifiable through changes in lifestyle or environment. It is estimated that between 30 and 50% of all cancer cases can be prevented by a healthy lifestyle, avoiding exposure to occupational carcinogens, environmental pollution, and prolonged infections. Tobacco use, diet, physical inactivity, and obesity are the main modifiable risk factors, and I will talk today about one of them. The World Cancer Research Fund International is a leading organization in cancer prevention research related to diet, obesity, and physical activity. It's a nonprofit organization that leads a number of international networks of philanthropic organizations that work in this area of cancer. These philanthropies are based in the United States as the American Institute for Cancer Research that you may know, the United Kingdom, the Netherlands, and Hong Kong. And the World Cancer Research Fund International has published several expert reports that have been very, very important for the prevention of cancer. The first one was published in 1997. The second one published in 2007, in which I had the privilege to participate as part of the panel of experts, and then the third expert report in 2018. This is the webpage of the World Cancer Research Fund organization, and I hope that you go into that webpage that has a number of publications. The methodology for the generation of recommendations for cancer prevention used by the World Cancer Research Fund is very rigorous. It uses both epidemiological and experimental evidence. In the first case, it uses case control studies, cohort studies, pooled analysis of this type of studies, and in some instances, randomized clinical trials. The cohort and case control studies are used, usually are summarized through meta-analysis, including pooled analysis, that synthesizes the evidence and analyzes the evidence as a whole. And then we also used in the deliberations experimental evidence, studies in humans, in animal models, and in vitro studies to assess how strong the evidence was. The criteria for analysis and categorization of evidence is such that provides a standardized framework for the panel of experts to objectively categorize with very clear rules the evidence. This is very key. There is a panel of experts, usually experts in cancer, experts in the different risk factors, nutrition, obesity, physical activity, environmental exposures, of course, experts in animal or in vitro studies or basic studies in humans. And this team objectively categorizes the evidence with rules that are very clear. And of course, the expert panel can discuss certain risk factors, can upgrade them or downgrade them based on the factors that are probably slightly different from the ones in the rules. That's allowed, but it's something that really needs then a consensus. So in general, it's really following the rules. It allows establishing the probability that an exposure, for example, dietary, nutritional, or physical activity, is causally related to the risk of cancer. The criteria lead to 5 possible levels of conclusions. One is convincingly causal, that is the strongest evidence, followed by probably causal, a very strong but a little bit lower evidence. These 2 types of evidence can lead to public health recommendations. And then there is evidence that is not enough to make recommendations. The 3rd level is limited by suggestive evidence of a possible causal relationship. With time, this limited evidence may become probable or convincing. Then number 4, limited evidence with no possible conclusion of a causal relationship. And the 5th one is unlikely substantial effect on risk. The classification criteria, as I mentioned before, is very, very clear. And let me give you an example. For convincing evidence, which is very solid evidence or strong evidence, evidence should be strong enough to support a convincing causation judgment to justify recommendations for reducing cancer risk. Evidence should be strong enough that the conclusions is unlikely to change in the immediate future as new evidence accumulates. In other words, evidence is so strong based on so many studies that it is very unlikely that one study that has a negative result will change the conclusion, 1 or 2 or 3. That's also needed for evidence to be classified as convincing. And then we require all of the following: evidence from more than one type of study, cases and control studies and cohort studies, evidence from at least 2 independent cohort studies. This is very important. At least 2 independent cohort studies. You know that cohort studies provide the best available evidence after the experimental evidence. So we need 2 of them. Then absence of unexplained substantial heterogeneity within or between study types or in different populations related to the presence or absence of an association or in the direction of effect. In other words, if there is one study that has a very positive association and another one a negative association, and this is not really explained by the design of the study or the type study, or there is in different populations very different results, then the study will not qualify to be considered convincing. Good quality studies, to exclude the possibility of systematic or random errors, confusion, measurement error, selection bias, presence of a plausible biological gradient. So we need really to see a dose-response association, and then strong and plausible experimental evidence, either from human models or from relevant animal models or in vitro models, but you need strong and plausible experimental evidence. And then the exposure should be typical for humans in the sense that, you know, there are some exposures that may not be found in human population, and you really need to place this risk in the usual a population that lives in freely in a country or region. So as you can see, this is very strong evidence. Then probable evidence is also strong or solid, but evidence is also strong enough to support a probable causal relationship. We need at least 2 independent cohort studies or at least 5 case control studies. So in this case, you don't need to have both types of studies showing the same results. Also, absence of unexplained heterogeneity and good quality, and then evidence of a biological pathway, but you don't need strong and plausible experimental evidence. But you can see that still, this is a very strong evidence that allows recommendations. I'm just showing here as an example the type of meta-analysis that we use for judgment. This is a meta-analysis of colorectal cancer risk for an increase in BMI of 5 kilos per square meter. And you can see that in this case, the type of association is an association in which if you increase BMI by 5 kilos or more, you also increase the risk of colorectal cancer. If you can see here, the line, the unity line, that is the line that shows no increased risk, is the unity line. And then you can see that the results here in squares are always above, which means that the risk is increased as a result of exposure. And of 38 of 57 studies included in the review showed increased risk of colorectal cancer of 5% or more for every 5 kilograms square meter. So the relative risk is 1.05. The confidence interval do not cross 1. And the total number of cases in these studies is 71,000. So, this is the type of evidence that we show. Then this is, for example, an evidence of how BMI, as BMI increases, the relative risk increases. So you do see a dose-response association. This one is also a meta-analysis now of postmenopausal breast cancer risk for increased BMI of 5 kilos per square meter. And again, you see that most of the squares are above the unity line. The overall estimation is also above unity. So the relative risk is 1.12, and the confidence interval goes from 190 from 1.15 cases. So this is the summary of the results of the association between body fatness, different indicators of body fatness, and risk of cancer. So on the upper right side of the figure, you can see increased risk for the 2 different exposures. One is adult body fatness, and the other one is adult weight gain. And this is convincing evidence of increased risk. And you can see that for adult body fatness, the cancer of esophagus, pancreas, liver, colorectal, breast, postmenopause, breast, endometrium, and kidney, they are all increased as a result of adult body fatness and at the level of convincing. And then adult weight gain, postmenopausal breast, also convincing, again, for breast cancer in the postmenopausal period. You can also see at the level of probable adult body fatness associated with mouth, pharynx, and larynx cancer, stomach cancer, gallbladder, ovary, and prostate, by the way, advanced prostate cancer. So you can see amazing how body fat or weight gain or BMI are associated very strongly and with many different cancer sites. It's really amazing the effect of body fatness. The only case in which body fatness may be protective, this is in breast cancer in the premenopausal period with adult body fatness and body fatness in young adulthood. So that means, you know, that young women who are during the reproductive period, in those cases, weight gain, increased weight gain is associated with a reduction in breast cancer in the premenopausal period. It doesn't include postmenopausal cancer. So this is really impressive because if you look, weight gain, overweight, and obesity increases the risk of 14 cancer sites. At the convincing level, esophagus, pancreas, liver, colon, and rectum, breast, postmenopausic, endometrium, and kidney. And at the probable level, mouth, pharynx, larynx, stomach, gallbladder, ovary, and prostate. Given the importance of weight gain, obesity, BMI as a risk factor for cancer, the World Cancer Research Fund made an exception. The World Cancer Research Fund looks at risk factors for cancer. And in this case, it looked at risk factors for obesity, because obesity is such an important risk factor for cancer. And it is interesting. I think that these results are very important. The World Cancer Research Fund really did an excellent job. And if you look at the risk factors, let's look first at those that protect for obesity, that decrease the risk of overweight and obesity. At the convincing level, walking, that is physical activity. At the probable level, our aerobic physical activity, again. Foods containing dietary fiber, that is fruits, vegetables, legumes, nuts, all those, and of course whole grains, all of those that have dietary fiber are related to lower risk of obesity. The Mediterranean type diet, a very healthy dietary pattern, also associated with less risk, and having been breastfed, very important. A baby who has been breastfed has a lower risk of obesity through its life. Then increases the risk of overweight and obesity, screen time in children, that is sedentary behaviors, sugar-sweetened beverages. And let me emphasize, sugar-sweetened beverages are convincing, at the level of convincing. It is very important that sugar-sweetened beverages should be reduced. We should advise people to reduce their intake or eliminate its intake because it causes obesity, and in turn, obesity causes cancer and many other diseases. Screen time in adults at the probable level, again, sedentary behaviors, fast foods, that's very unhealthy foods, very high in sugar, in fat, energy-dense foods, usually also consumed with sugar-sweetened beverages and so on, and the Western type diet. And I will end up with a package of recommendations for the prevention of cancer, emphasizing the ones that I have presented today. The first in the left is be a healthy weight. So maintaining a healthy weight is a great measure to avoid overweight and obesity. Then I also presented evidence that indirectly, if you limit the consumption of fast foods, also in the top left, and other processed foods high in fat, starches, or sugars, you reduce the risk of obesity and therefore reduce the risk of cancer. And then limit the consumption of sugar-sweetened beverages, again, as a very important recommendation. And for mothers, breastfeed your baby if you can. It has two different mechanisms. One goes to the risk for the baby, which is reduced as a result of breast milk because it reduces the risk of obesity. But then there is a direct association of breast milk with reduction of breast cancer in women who breastfeed, So therefore, breastfeeding is a very important recommendation. And of course, there are many other recommendations. Of course, it was not part of my talk today, but be physically active, eat a diet rich in whole grains, vegetables, fruits, and beans, limit consumption of red and processed meat, limit alcohol consumption, and after a cancer diagnosis, follow our recommendations if you can. Of course, along with other exposures that are not diet, physical activity, body composition, like tobacco, like also sun exposure, high intakes of salt, so on. Those are also very important exposures. Well, thank you very much. It was my pleasure to be part of this Congress, and I really appreciate the invitation. Thank you.